Good morning, everybody. I'm so excited to engage with you. AI can be used for lots of things, but we all know AI is pretty central to what we need the enterprise today. I certainly hear it a lot from our board. Where are you leveraging AI? How are you growing your business faster with AI? How are you driving efficiencies with AI? All of this ties to how do we enable that agentic enterprise. So with that, I'm going to start with product today. So here's a video of what we just announced this morning. I'm going to talk a little bit about this. This is our next generation Lakehouse experience, focused first and foremost on exploratory analytics. And what you see here is, of course, a standard agent model, but we've enhanced it between system prompts, guardrails, permissioning, as well as the fundamental semantic layer we have within Dremio, which means we now have an agent that is not only doing SQL to text, or text to SQL, of course, but also leveraging underlying models, multiple models, to drive analysis and exploratory work. In fact, I no longer use Tableau within Dremio. I actually use this. It's a pretty fundamental change for me. From that, I now can do analysis and analytics on top, not just querying and discovering data, but perhaps I want to do analytics on the data. And this is with our sample data here. It's part of the demo. And you can see it computing and pulling through values together. It's showing me the Excel, or excuse me, it's showing me the SQL. And now I can see visualizations as well. I don't need to go to Tableau or Power BI or other systems, all right there. And so from that, I can then go and say, well, I want to do comparative analytics. Again, all in the theme of exploratory analytics. So as a business user, as somebody who didn't write really any SQL in this engagement, I'm not able to do complete analytics. I no longer need to go to my FP&A team. And oh, by the way, I can actually ask the AI, convince me this is accurate. Show me how you got to this. Show me the lineage. Show me what's the semantic layer. And you can see with this graphic a comparative analytics on the sample data set we have. This is the power of AI. This is the power of not just AI independent, but power of AI with a semantic layer. So this is what we're going to dig into this morning and what makes Dremio so unique. Good morning. I'm super excited to be here today. Talk to you about the Agentic Lakehouse and, of course, the Agentic Enterprise. What does that all mean? We're going to dig in a lot deeper into the product areas, what we announced today, and of course, how you can take advantage of it as soon as possible. As you all know, and as sort of Reed indicated in his initial engagement here on the survey, we all use this every day. We all know individual productivity has actually been delivered. And this continues to get better every day, whether you think about Gemini, Claude, Anthropic, et cetera. And the benefits are real, and the benefits are certainly at the individual level. And if you look at actually what happens in a traditional enterprise, that sort of stops there. In fact, you saw it in the hand raisers that were here. You're not connecting your AI to your enterprise data. You probably don't trust it necessarily. And you're also not applying it to broad-based automation. And this is a recent study by MIT. Only 5% of organizations are getting a return from AI. This is not our data. This is MIT's data. Though 80% are certainly investing and trying to work. In fact, I saw a survey from one of our engineers, or a press release from one of our engineers this morning that said Meta was deploying a $1 billion data center. I don't even know how you can fathom that, but there we are. So what does that all mean? Certainly NVIDIA is getting stock, and that's going well. But what does that mean for AI in the enterprise? Well, we know there's lots of potential. We all want to make this work, but we're struggling to make this work. What is it going to require for us to be successful here? And so what do? I go to Reddit. And these are some memes I got from, none of these we created at Dremio. All of this were from memes that you're probably data engineers either in the audience or in your teams created. And I love these memes. In fact, I feel like I'm the dude on the far right here, where like I'm sitting there asking for AI to our engineers, and they're like, buddy, do you have any idea how much this data is trained on? Roll the dice. Congrats, have fun. And this is the reality of what I think our data teams face every day. Data quality issues, what data do I trust, what's being described correctly, what's the lineage, but everyone's saying AI, AI, AI. How do we make this work? So we know the foundation is super important. And this is the reality that our engineers are facing every day. So how do we make this work? How do we think about this from a maturity perspective within the enterprise? And how do we get to the type of things that our boards and our executives want in the data space and in the AI space? So we thought we'd put together an enterprise maturity model. And we did this because we think it's important to look at this. Too often we think about AI as a nirvana. It's not. You have to work your way towards the outcomes that you want for your business. We certainly start first and foremost with individual productivity. That's a Claude, ChatGPT, we're well aware of that. The second then is I think a place where several of you are still kind of looking at this, and not a surprise, frankly, given the customer conversations I've had. When you look at this, this is about taking your analytics that you're doing at an individual level and then tying it to your enterprise data. We recently launched an MCP server. So does everybody. A lot of vendors in the space have done that, not just in the data space, but also in the application space. So we believe this community of MCP will continue to enhance. But to make this work, you also need a semantic layer, which obviously Dremio provides. Why is that important? Because last time I checked, your columns are not labeled perfect descriptions to be able for the semantic or for the AI agent to work well. You need a semantic layer. So we know stage 2 is an important piece of the puzzle. And this actually significantly enhances productivity. In fact, I don't go ask my support team for Zendesk ticket information. I go to the agent and I say, please give me an analysis of the last 90 days of tickets for customer X before I go talk to the customer. Or what were the last 10 interactions my sales team had with the customer? I don't need to go ask it. I don't need to log into Salesforce, okay? I don't need to log into Zendesk. I ask the data and I get results. And I can trust the data because it's based on our semantic layer that we've already defined within Dremio. Very powerful. We believe organizations will move to this model. Why? Because you already have that expectation at home. You have the expectation, just like mobile, frankly. We all got to mobile first in the consumer world and then went to the enterprise. We're going to see the same thing happen. We're going to see enterprises require, users in your enterprise require the de facto model of engagement to be that chat experience. It is a standard already becoming what we do every day. The third is around individual productivity. Okay, now I've done an analysis of this data. I want to take some action. I guarantee you no one's going to say, let the agent run free in your enterprise. I certainly wouldn't. But what we do know is at an individual level, with your access tokens, with your permissions, with your authorizations, could it do something for you? And that little something could be something like, oh, I need to send an email to the customer, to the sales teams that I'm going to go talk to next week with some basic information of what I need. Well, that requires plugging into an MCP tool. Now I can do that. So automatically, we can drive automation in this model. This is the next step, and you'll see Dremio continue to enhance here. We're going to continue to add MCP tools in what we do, and more of this will come as we talk about this later today. And of course, finally, the Agentic Enterprise. And I'll tell you, we put this last column together because we do believe over time agents will start to communicate together, but we know it's some time away. Why? It's not a technology problem. It's a trust problem. None of us will trust an agent to go do everything willy-nilly in an enterprise. It takes time and effort, and it takes trust. And so that'll be part of how we think about enabling that agentic enterprise, is trust and data confidence is going to be very critical. In fact, in our CAB, we had our customer advisory board yesterday here in New York, and the number one thing was, I can't trust what comes out of the AI. Until I can trust it, I can't put my job at risk for not having that. So really important to have that semantic layer to build trust. I'm going to double click on all this. So as I said, the reality is most of us are here, and certainly the hand raisers reflect that. Now, we did that recent survey, as mentioned by Reed, and the number one challenge for adopting AI, lack of AI-ready data infrastructure, lack of unified AI-ready data infrastructure. How do I pull these pieces of data together? Because that context and that information is so important to make AI effective. Just like in my example, I needed to pull in Zendesk data, Salesforce data, et cetera. How do we bring all these worlds together? The number one reason, and we're hoping to help solve some of these problems for customers. But if you look at actually what's happening also from an infrastructure standpoint, 95%, so the 32 plus the 63, are the organizations that are looking to leverage a lakehouse as the way in which to support AI initiatives. We're obviously very biased and excited about that. We think it's the right answer, which is why we're obviously very deep in this space. But what's interesting is that 63% have already started to deploy lakehouses as the fundamental mechanism for AI. And of course, another 32% are looking to bring this on board. Now, what does a great AI foundation require? What does an open foundation require? Open Lakehouse, Parquet, Iceberg, Polaris, and of course, Arrow. I'm personally very excited about Polaris. It's a multi-vendor project. It's a true open Apache project, which I love. Big fans of Apache here at Dremio. And why do we love it? Because it's an open catalog. It's vendor agnostic. It allows you to move around in the industry. And we know, because it supports the Iceberg REST interface, we know multiple engines will support it, as they already do. And we know multiple vendors will support this mechanism even as you move across vendors or as you sort of continue to adjust your technology architecture. A lot of folks I know are still using glue, hive-based approaches. We know this is the next generation approach. And we're going to talk a bit about the type of things we're doing collaboratively with the community around Iceberg and Polaris to drive advances. And as some of you may know, we're the original authors of Arrow. Okay, with that foundation, now what's next? How do you enable a Agentic data platform? We think there's two fundamental requirements, if you will. You have to feed AI systems. You've got to feed data and context to these AI systems, because the last thing you want is someone using Claude over here and saying, what's my sales in Q2? And then ChatGPT over here and what's my sales in Q2 and getting two different answers. That wouldn't work. That pretty much DOAs your AI initiatives. Because the minute they lose trust, they're not using AI anymore. Users aren't using AI anymore. Second, you need a data platform that adjusts to the world of AI. What do I mean by that? Well, the historical model is today, when you go and ask for a new data set, you go to a data engineering team, they build a data pipeline, you wait several weeks, you get their data results, like, oh, I forgot these other 5 columns I need, or these other tables that I need. They go and then redo some elements of the silver and gold layer, and then you're back at the same model. How do we accelerate this fundamentally? Because the agent is not going to create a requirements document for you back to the data engineering team. It's going to keep running new questions. It's going to change the queries that it's running. And while a semantic layer will help assist and ensure consistency with some guardrails, you want the AI to be flexible to deliver the type of queries and analysis that you need. How do we make this work? But when you look at the actual applications, whether it's not just Dremio, but frankly, in an enterprise, you're going to have SaaS applications. In fact, I suspect a lot of you are using Copilot from Microsoft's ecosystem, yes? Guess what? That's an AI silo. We talk about data silos, that's an AI silo. If you use Copilot within PowerPoint as an example, that's an AI silo. If you use Gemini within Google Docs, that's an AI silo. So we know these silos are going to exist. So how do you fix that problem? You need to have a consistent view of data. You need to have it be real-time accessible. You need to also share the context. And you need to make sure multiple models can be used. So we know these pieces are major components to making this happen in an enterprise. And so we've broken it down kind of to 4 pillars we believe are important. Number 1, you want your platform to access and have complete level of information. Number 2, you want to have context to all the data you're looking at. Because without context, you cannot give AI high accuracy. Number 3, it has to be governed, of course. We know that, RBAC, FCAC, et cetera. But you also need the right data quality, because without the quality and the lineage, no one's going to trust the data. In fact, you wouldn't trust the data, because you're going to ask the question, where did this data set come from? You need to empower the agent to have the same level of information. And of course, you need a platform to be automated, because the world of manual data pipelines, it's gone. The agentic world will require something fundamentally different. And that's what we've been building at Dremio. So I want to double click on each of these pillars. I want to spend a bit of time, because these have to translate into capabilities for folks like Shah and others to be able to leverage. We talked about complete, contextual, governed, and automated. Let's double click on each of them. So first, complete. We want to get the full picture of the data. The full picture of the data first means you have a lake-centric approach, lakehouse-centric approach, leveraging Iceberg, which I think we're big fans of. We've already seen Iceberg v3 come out. We've already talked about specs for v4. We're going to see convergence of the table formats into Iceberg as being the primary one. Second, you're going to see a data catalog, the metadata catalog. And of course, we have Dremio's open catalog with Polaris as a foundational pillar of that. So you've got that in kind of one place. From that, you want to make sure you're looking at both, you want to look at multimodal data, as Shah mentioned. That wasn't historically the case for data lakes and lake houses, but of course, AI has now enabled that. And we all know that 90% probably of your S3 bucket is unstructured data, and from a value perspective. And so how do we get access to all that? We're already seeing customers convert audio files into transcripts and so forth. And then the third piece is around query federation. How do we bring not just query federation, but our reflections capability and accelerate the time in which an agent can find information and then can then derive insights quicker? Because if you have to, again, a priori set up everything, you're not really helping the agent and empowering the agent to do what it needs to do in analysis. That's complete. Second, contextual. Well, I think we've talked a little bit about what contextual means. And I'll give you my example. How do agents understand basic terms? Of course, we have things like metrics and so on, but I can tell you, if I'm sitting in the revenue organization at Dremio, when I say the go-to-market organization at Dremio, when I say revenue, they all think annual recurring revenue. That's what their quota is based on, okay? When I say revenue within my finance organization, they say ASC 606 GAAP revenue. So how does the agent know not only that the word revenue means a certain metric, but the context of the question matters? So all this has to be woven into how we do AI. Because if I said revenue to the finance team and it comes up with ARR, they're being held accountable to a GAAP standard. They have to get this to work. This is where, fundamentally, a semantic layer is important. Not just a semantic layer at a global level, at a departmental level. You've got to bridge these layers together. You have to ensure what it means for the finance team is different than what it means for these other departments. And I'm sure in some of the regulated industries in the audience, the banks, these things mean different things. Right? What does trade flow mean? Well, it probably means different things with options versus equities versus real estate, et cetera, based on the asset classes. And how do you make sure that you teach your AI to either give it all the context, and then it's going to hallucinate, or how do you then drive these pieces together? So the semantic layer is fundamentally important to knowing this, and we have always invested in the semantic layer. You're going to see us do a lot more here in driving things like ontology, relationships, and tiering that across what we have already in the system with regard to layering the various information. Third piece, governed. Security, quality, compliance. That means fine-grained access control, of course. It also means row-level lineage, which is coming in Iceberg v3. It also means policies and enforcement, all critically important. And because via MCP and via agents, they're all leveraging that same framework, they get to take advantage of all the things available. Why is this so important? It's not just about saying I have security and I have secure access to my data. That lineage is important. Why? How do you tell the agent, when you ask the agent, hey, please tell me how you got to this analysis? If it doesn't have the context of the lineage, what's going to happen? It's going to say, I don't know. I pulled it from this table. What does that table come from? Well, I don't know. So now you're back to the business user calling the central team and saying, can you give me how the heck you put this data pipeline together? Then you haven't really accelerated your productivity. You've gone back to the same old world of ETL pipelines, having to be managed by one team, and then having to be, knowledge is different across SMEs. We want to democratize this, and AI affords that opportunity. And fourth is around automated. I'm very excited about this one. This is where we're putting a lot of our effort within the company. As you all know, we've been big believers of this concept called reflections. We have invested significantly in this area, really over a 2-year period. Tomer's going to talk a little bit deeper in this area. But what we've actually done is not only first done Iceberg clustering. We're the only vendor in the industry to do Iceberg clustering, which means you no longer need to worry about partitioning. We've also now taken our reflections technology, which required a mix of query analysis and rewriting. We have now applied that in an autonomous way. What does that mean? You flip on autonomous reflections, and it starts analyzing the query patterns of not only your team, but the agents that are searching the system. And typically, agents are running 10 to 20 times more queries than a user. Okay? 10 to 20 times more queries than a user. Sorry about the AWS bill. I'll just say that up front. Right? So what does that mean? That means we got to get smarter as a data platform team. Either you do a bunch of manual work, or you got to let the system manage it. So what do? We actually analyze all this and automatically drive accelerations in the technology. And we turned this on at Dremio. Next day, I was talking to my head of PS. He's like, man, all my queries just got faster. I don't know what happened. I said, oh, it's funny you say that. We turned it on yesterday. And all of his queries went from like 10, 12 seconds to sub-seconds. Pretty powerful. With zero work on the part of the data team. Our data team is one person. Didn't have to do anything. That's the power of this technology. So very excited about this. You'll see us do a lot more here around driving autonomous performance in the platform. That's one part, but what about the rest of the things that happen on the platform? Data engineering, analysis. You're going to see us incorporate all this into a multi-agent system within Dremio. Every agent will be able to leverage multiple models, system prompts, tools, and of course the guardrails. Not only will we provide out of the box, but also what can be customized within your organization and by department. We want to make this enterprise grade and ready. That is our goal. And so we're very excited about this. We're going to have a lot more demos, and Tomer here will be spending a lot more time talking about these pieces. So 4 pillars: complete, contextual, governed, and automated. Now with that, I'm excited to announce this morning we launched, and if you haven't seen it yet, our next generation of Dremio Cloud. The video you saw was exactly that, all driven with an AI-first experience. This is a platform for the next generation of Dremio. It is that Agentic Lakehouse that I mentioned earlier. I know several of you have your phones out, so I'll just let you, let's see, we'll go one more slide. There we go. So if you can get your phones out, this gives you the QR code to log in and drive through and hit all the sort of examples that we showed earlier. So jump on, probably harder to do on your mobile phones, but at least you have the URL, check it out on your laptops. And so I was playing with it this morning, doing analysis within Dremio, within our internal data lake. So definitely check it out. It's our next generation approach. One, feel free to pass on to your colleagues as well. Okay, now I've given you an example of what that is. Now let's hit on a concrete example of what customers have already started to do with this Agentic Lakehouse. I want to talk about one of our customers here who is a regional bank. They do credit authorization memos. How many of you have done a home loan before? Yeah, most in the audience? Okay, a lot of renters, I guess, in New York, right? Home loans. Well, last time I checked, when you get a home loan, you need a lot of information. You send some info, and what do? They send you an email back. Hey, can you send me where you lived 3 years ago and maybe these bank statements from this other person? So now you've got to amalgamate all this information together. We said, well, this takes weeks for this bank. How do we accelerate this process? Well, a lot of this information shows up either via APIs, in the lake, in structured and unstructured formats. How do we make this more effective? How do we drive 10x productivity? And so this is a visual of what actually happens now within our Agentic Lakehouse. That unstructured data drops onto the lake, PDFs, what have you. Use our AI generate function, which is our new SQL functions for AI, extracts that information out, and puts it into a structured Iceberg table. Now I've got the structured Iceberg table. I've also got the data that already sits in our semantic layer, which may be a customer 360 information. It also may require you to federate out into other systems. So now I go from that, combining unstructured and structured data, all leveraging the underlying AI models as well, putting that all onto Iceberg. One, you have a record of that all in Iceberg, wonderful. And now you can generate out that PDF. That's exactly the example. And so this is a visual of what exactly that memo looks like. All done, coming out of Dremio. All leveraging AI, again, in that Agentic Lakehouse approach. All leveraging structured and unstructured data. This is the power that we can do with the Agentic Lakehouse. And you can see we're leveraging whatever templates the bank would have. This is a fairly straightforward one from a POC we did. And so now the bank's deploying this in a production scenario with lots more data sources. So what does this ultimately mean? It means we took the world of manual stitching of data everywhere, data sprawl, we all know this. And we know it's never ideal, and it's never really possible to put all the data in one place. We all think we do that. We go through these ebbs and flows. We put a bunch of data in one place, and guess what happens? A few more teams deploy new systems, et cetera. We want to make this easy and effective. So Dremio brings these worlds together. It brings a semantic layer. It brings trusted decisions. Ultimately, the idea is not just to have technology acceleration, but individual level, enterprise level productivity to drive that agentic experience. Because ultimately, for us, we want AI to be an equalizer. We know you will have productivity at the analyst level, at the engineer level, at the business unit level. But we also believe AI will drive a blurring of lines. It will be an equalizer across most roles in an organization. As I mentioned earlier, yes, I'm more productive in doing my analysis, but I no longer need to hit the FP&A team with questions. I now have become an FP&A analyst in a way. I may not do the whole job, but man, I could do half of what I need to get done now. That equalization is going to also apply in the data world. We fully expect that business users will become data analysts. And data analysts will start to do more things in the data platform level. They'll be able to start to do ETL pipelines. Perhaps not at the bronze layer, but certainly at the silver and gold layers to start. But all AI will help enable and empower that. So we're big believers on this, and that is what we believe is required to drive an agentic enterprise. So we know an agentic enterprise will require an agentic lakehouse. That's what we're very excited about. And speaking of an agentic enterprise, I want to bring on stage our next customer. He is driving an agentic enterprise transformation and bringing data from multiple silos together. With that, I'd like to introduce Carl Smolka from 3D Securities. This is how we do it.
good morning, everyone. Yeah, it's nice to join the lineup of executive Dans with receding hairlines. Yes. Sorry to break it, guys. For those of you who don't know me, my name's Carl Smolka. My day job, I'm trying to run the data platform team at TD Securities. Ignore the accent, I'm based out of Toronto. I'm just an Englishman in New York for today. So, coming back to this theme of, the maturity curve, I'm going to be just sharing a few insights around, we're coming into year end, and what are some of the things that I'm thinking about to try and push my organization up that maturity curve. So I'm by no means an AI expert. I'm just someone that's sitting in the middle of this journey, and I'm going to share some insights with you today. Okay, so who are we? So hopefully for those of you who are from the local area, you will recognize the green TD shield. But for those of you who don't, TD Bank, Toronto Dominion, number 2 in Canada. And I think depending on which metric you use, we're somewhere around 15 in the world when it comes to the investment banks or capital markets arm. So I specifically work in the cap markets arm of TD Bank. But what are our ambitions? Our ambitions are pretty simple, really. We want to be top 10, right? And I think as an organization, we know that if we want to not just grow, but just exist in the future, having a great data strategy is it's table stakes nowadays for any big organization. So let's zoom out quickly. What is our strategy? Well, it's very hard to get data strategy or a complete data strategy onto a slide, but this is my attempt, and I quite like it. So, this is when I roll out to the super execs when I'm trying to explain things very quickly. And the first aspect of our strategy is accessibility. There's nothing worse than going into an organization and having to go on a fishing trip around the organization to work out where a bit of data resides, right? We've all been there on that one. And I'm a big believer, just give people access to data, obviously with the right guardrails, but lower the barrier of entry for accessing data. That's a huge part of it. But secondly, quality, right? There's nothing more demoralizing than when you spend hours producing a report, stick it in front of a trader, and he goes, no, wrong, instantly, nothing. You've just wasted all that time, right? So if you can't trust the data, then you're going to be in trouble. And lastly, you've got to get some value out of this thing. And we're going to talk about this today, about the value thing, because, at the end of the day, we're not doing this for fun. We want to make or save some money or, and drive some ROI in some respect. But let's talk a little bit about how we use Dremio. So we started on the Dremio journey about 4 years ago now, I think, give or take. And, the interesting thing is, I'll say this from the bat, and the guys don't mind me saying this, is we are not exclusively a Dremio house, right? We're a huge organization. In fact, I think last time I checked, we're somewhere in the region of top 20 Databricks customers in the world, right? But that being said, right, we are using Dremio. We love the product. We sort of use it as a data fabric primarily. And coming back to that sort of first prong of the strategy around accessibility, the reason we really started with this was to break down the data silos within our organization. Right, the path to where we got to today was not simple, and providing people access to these federated data sources using their query federation and this unified interface has been a huge win for us. So we've got some stats up on the screen. I mean, these aren't huge numbers by capital market standards, but the thing's growing pretty quickly internally. So, we're now at the phase we're starting to think about, right, we're now upgrading Dremio, and we're excited to start leveraging some of the new features around autonomous reflections. But the key for us has been in their approach to self-service. The thing I love about Dremio compared with a number of people in the market is that they think about that self-service aspect from the word go, right, even compared to some of the bigger players in the market. Okay, but let's zoom out a little bit. Another maturity curve, very similar to what Sendo was talking about earlier, but I've stolen this one from Gartner. And the reason I put it up on slide is because it resonates with me, right? I think it's easy when you come to these conferences to think that everyone else around you has nailed all of this stuff. Here's the dirty secret, they haven't, trust me. And probably this is a skewed audience. So like I say, what I'm trying to work out now is we're at this point where, most organizations are stuck around sort of phase 2. What are some of the activities and some of the things we've got to be thinking about to move us up that maturity curve? with the end nirvana being this true democratization of AI across our enterprise to weaponize our data. One of the things we're seeing in the market, especially within the big organizations, is we're actually starting to, right from the top of the house, they're starting to ask questions about when are we going to get value from this AI thing that people keep talking about, right? So we've all been in this bit of a honeymoon period where we've been playing with this technology. There's been a lot of hype about it. But now we're actually seeing that our CEO and president of the whole bank is actually starting to make very public commitments about how much we expect. And rightly so. We've spent a lot of money on this thing and on our data strategy. So what's the return we're getting? So that's a theme that I think a lot of organizations are going to see in the next, if not already, in the coming months. So what are the things you need to do? Well, every organization is different, but I will say this with pretty much some certainty. And we've heard this already today. Data readiness, huge part, right? We've all heard the adage, junk in, junk out. It couldn't be more true to AI and data analytics. So as an organization, we have been hyper-focused on adopting what we call this data product mindset, right? Even to the point now where the enterprise is tracking across our different lines of businesses the maturity of our data products. And really what that's meant is we've developed some fit-for-use models and data in-house that is the bread and butter of our industry. Think trades, market data, reference data, that sort of stuff. And we started on this journey about three years ago. And interestingly, we're already starting to see quantifiable returns on our investment from generating these data products. But data readiness is so much more than just modeling your data and getting it into a single bucket or a single technology. As we've heard before, context is everything. And part of this data product mindset is capturing the right information to give AI context, be it metadata and all the good jazz we do with data catalogs as well. So yeah, so that's been a big priority for us. But let's take a bit of a sidestep right now, because I'm imagining that a lot of people in the audience are working in sort of data or tech teams, and there's huge AI and data frenzy right now. And at times, I don't know if it resonates with you guys, but it can almost be difficult to know where to start when it comes to rolling this stuff out. So I'm just going to share with you a very simple framework that we've been putting together with some of my team here to think about, right, when it comes to the formal build, not experimentation, how are we prioritizing our use cases internally? And the way we've done that is by developing a very simple framework that has 4 pillars. The first being process, right? For any given use case that comes to us, do we have the right processes internally? That can be anything from operating procedures all the way through to AI readiness forums, governance, data management, etc. They need to be in place before you go. And also you need the data, right? If you don't have access to the data again, difficult to hit that use case. Thirdly, do you have the right capabilities? We saw from that slide that Sender put up, getting access to some of these tools in bigger organizations can be a pain in the arse. In fact, it is for us. So rolling out capabilities is a big part of it. But lastly, one of the things we've been focused on recently is starting to think about the value statement of a given use case, right? And the way we think about that is on 2 different dimensions. What's the value or the ROI that this thing is going to return? And when is it going to do that? What's the time horizon for that thing there, for the use case that you're talking about? So we've been using this framework internally to start thinking about, right, okay, if all 4 of these criteria are met for a given use case, it's probably time to start thinking about building this thing properly in production. Okay, so to wrap up, what are some of the top things that I'm thinking about going into next year? So, like I say, data readiness, huge part of this, right? Yes, this list here that I'm putting up is by no means exclusive. These are just some of the things that came to the top of my mind when I was preparing this presentation. Data as a product, huge thing, and I think, like I say, we're already starting to see the return on our investment, having completed a number of different regulatory regimes as well. Secondly, pick the right technology vectors, right? The industry is changing at such rapid pace, you don't want to be betting your house on any single technology right now. And one of the things I love about Dremio is their commitment to using open standards, right? Avoiding that vendor lock-in. Gives me confidence that I can use the product, and should the landscape change, we can always change tack there slightly. Third, technologists, this is not just the responsibility of the business. You need to start thinking about why you're working on something, what is the value of it, and what is the ROI. You're going to see more and more pressure on tech teams in the coming months to actually explain why you're doing stuff, right? The honeymoon period is starting to come to an end. Lastly, establish governance. Yes, sometimes this can be the least sexy part of data, but it is fundamental. Whether that be your AI readiness forums, responsible AI, data management forums, whatever it may be. Every organization is different. That is absolutely fundamental, and that needs to be in place. Okay, so should you guys go out and copy this? No idea. I'm not your mother. Work it out. But these are things that are top of my mind going into next year, and I think most of them will probably resonate with the people in the audience. So I'm super excited to start playing with some of the new features of Dremio, and I think some of the stuff that they're going to show you later, I had a sneak peek of it yesterday with the semantic layer stuff in it. Yeah, it was spot on, guys. So with that being said, thanks, guys, and I'll hand back to Sender. Thank you.
Thank you.
Cheers, sir.
Thank you. I love the user growth, like 254% user growth. Pretty powerful. Getting access to data. We all want that. We know our users want that as well. So thank you, Carl, for that cover. Okay. Lots of great info about what's happening with customers. Lots of great use cases. But I'm just maybe talking figurehead here. The guy that's sort of helping all the details on the product side with our founder, Tomer Schrin. Tomer, come on stage.
Thank you, thank you. All right, can you hear me? Yeah, okay, cool. So it's great to be here. There are 3 things I want you to take away from my session today. Number 1 is that it's possible to work in data and have a lot of hair. So don't, in case you got the wrong impression so far this morning, do not worry. The second thing, it's great to be in New York. You guys just had a new mayor kind of election here. Sounds like there's going to be free buses, free childcare, free pizza, free lots of things. But even if that doesn't work out, okay, you have $400 of free DCUs from today. So that, I promise you, will work out. You're on Dremio Cloud, and it's great. And then the third thing is, what I'm really going to focus on today is what's possible with an Agentic Lakehouse, okay? All right, so let's get started. I think a year from now, very few people are going to be writing SQL by hand anymore. I think it's going to be the new kind of like an assembly type thing where you do other things. You write in other languages, like English, and you don't have to worry about that language, right? And so we see this already when we're dealing with agents, right? And whether these are agents that are running autonomously or just like assistants, things like ChatGPT and Claude and Claude Code and Cursor and things like that, right? We're using these agents. And those agents then have to go and work with the data platform. They have to write the SQL. They have to understand the data and so forth. So in order for that to work, Sender talked about it, we need to have a platform that gives you complete access to the data, all the different data sources that you have in the organization. It has to understand the context and the business meaning of all these things. The data has to be governed, so the quality is there, the data sets are up to date. And then finally, the performance has to be automated because our agents don't yet know how to go, walk down the hall, talk to the data team, ask them to optimize the data, right? They have to come to a platform where they can just run queries and things will be fast. And even if we do get to that point, it'll be great, right? We'll all focus on our hobbies. We'll go play tennis or go skiing, and it'll be a great world. But for now, the agent has to, it can't go talk to a bunch of people. It has to go to a platform that can just make things fast. So what does that Agentic Lakehouse look like? So if we start at the bottom, we have an open catalog that's responsible for kind of maintaining what data we have in the organization, what's in the object storage, what's in the existing, external data sources. Then we have the intelligent query engine on top of that that's responsible for connecting to all the different kinds of data, structured, unstructured, external data, unifying all that information, making it fast. We have the semantic layer, which presents the business context, the meaning of different columns. And then we have, on the right, you see here, the autonomous management. So this is responsible for, in the background, making sure things are fast, clustering the Iceberg tables, creating reflections, things of that nature. Then finally, at the top, all sorts of different kinds of agents. Let's dig into these components one by one. So starting with the open catalog, Dremio, about a year ago, we co-founded a project along with Snowflake called Apache Polaris. really the next generation open metadata catalog or metastore, right? This provides end-to-end access control, as I'll show you in a second. So Polaris, we just had the 1.0 release just a few months ago in July, and already we have more contributors on Polaris than there are in the competing kind of more proprietary catalog, Unity catalog, right? And so already this is the fastest moving catalog in the market, most contributors, and for those of you who use things like Hive Metastore and Glue for many years, this is kind of that next generation, the more modern open source catalog. I won't get into every detail of what's been added, but there's been a ton of innovation. As you can imagine, with over 100 people contributing already to this project, it's moving very quickly, right? Every couple months, new sets of capabilities, new features, a lot of work on the kind of groundbreaking security capabilities to provide end-to-end access control, things like credential vending, integration across sources, support for both cloud and hybrid and on-prem object storage, all sorts of kind of interesting capabilities. At lunchtime today, Alex will be signing the book, so go find him and get your Polaris book signed here. One of the things I'm most excited about with Polaris is providing kind of that end-to-end access control, which doesn't end with the query engine. It actually goes all the way down to the storage. So everything from fine-grained access control, column and row level, all the way to being able to secure your storage, right? And the Polaris catalog is responsible for providing kind of granular signed URLs and doing credential vending so that no system, no query engine, no script has to actually be trusted and given access to the raw data. That's a big change from the past where if you had a data lake, every single engine and every tool had to be trusted. It had to be given full access to the data. And maybe that was OK for like an enterprise Lakehouse platform, something like Dremio, right? Some large distributed query engine. But certainly that was impossible to enable data scientists to write scripts, for example, and use Python to access data, right? Because you couldn't give every user access to all the raw data, right? You needed to have that control. So now that's possible. The clients that are accessing data no longer need to be trusted. They come to the catalog and they get permissions for a limited amount of time to the specific thing that they need right now after it's been validated that they have access to that table. So this is really changing the game, making lakehouses have that end-to-end security. You're not giving up any kind of security or access control relative to, say, an Oracle database or some data warehouse. Next, I want to talk a little bit about the query engine. So the intelligent query engine is responsible for unifying data access to different kinds of data. And so it used to be that this was really focused on kind of structured data. And even that was just kind of like Parquet files, right? Or CSV files in the object storage. But now it's a lot more than that. So if we think about the query engine that we have in the Dremio Lakehouse, you have the object storage. And now we support not only things like Iceberg tables and Parquet files and so forth, but also unstructured data. So the ability to go and query a directory of PDF files or images or videos and things like that. And then as you probably know, we also support connecting to external sources. This could be relational databases like Postgres and Oracle and Snowflake. It could be NoSQL databases like MongoDB and Elasticsearch. Other lakehouses, other object storage, lots of different options. I think there are over 30 different connectors at this point. And we have sophisticated caching capabilities that allow us to use the object storage to actually cache that when those systems are too slow. So you have this unified access that's enabled by having this kind of a query engine. One of the new things in Dremio is the ability to process unstructured data. And we do this through these AI functions. Right? So we have a function called AI generate, for example, that allows you to prompt an LLM, give it the unstructured data, like a PDF blob or an image or something of that nature, right? And it can extract structured data. If you're familiar with OpenAI and extracting structured data in the response to a prompt, something similar to that, right? So you just call it. It's a simple SQL function, and it allows you to process unstructured data. You don't have to go build a whole kind of data pipeline or application just to take 1,000 PDF files and extract some structure from them. AI complete, kind of similarly, but takes a text prompt, returns text. And AI classify is something that can classify data. So if you have, let's say, customer reviews and you want to ask, are these positive or negative reviews, right? It's as simple as using the AI classify function. You give it the options, and it will return that value. So all of these functions take unstructured data, turn it into some structure, into a table, a virtual table, which you can then join with other things in your lake, in external sources, create views on top of these. So it's all presented as just tables that can be analyzed or visualized. So let's look at a simple demo. And I'm going to have a few different components of this demo. But think of a simple company here, a company that has a call center, right? And in this call center, they want to do analysis of the call logs. They want to understand who the best performing support engineers are, what can they learn from these people, how can they manage performance, those kinds of things, right? And so that's what this company wants to do. And what they're going to do as step number one is make the data accessible. And so unfortunately, the system, the company is using a legacy kind of system. Every call is outputted as a PDF document that has information about that call, right? It's a transcription of the call and various kind of information. So let's take a look at what that actually looks like. So we have here in the object storage, we have a directory called customer support. And in that directory, there are many, many documents, many PDF documents. And so just to show you what that document looks like, a table here, kind of a table with multiple columns, various notes from the agent, so kind of unstructured data, really, right? It's a kind of a document, okay? So we don't have to go and write a bunch of Python code and maintain an application to a pipeline to extract it. You can see here we're using the AI generate function. We're providing the schema, basically what we want to extract from each of these documents. It's simple kind of SQL schema. And what we're doing in this case is we're doing an insert into of this select statement. Okay, so we're basically a very simple SQL statement. It's going to run, and it's going to insert all this data into a new table. There's a function called list files. So all those files are basically one table, and you can see that now we have a single table. Every row is one of those files, with the columns being that schema that we just created. So with a very, very simple SQL statement, which, by the way, we don't have to write by hand. We can actually use the Dremio agent, which I'll show you later, to create this SQL statement. You can take these thousands of PDFs and create a table with all that structured information, right? Super, super simple. That's the idea. OK, let's talk about the semantic layer. Because at the end of the day, it's great to have access to all the data, to be able to query it really fast. But sometimes, if you don't understand what that data really means, and in the real world, we've all seen what schemas look like. They're very hard to interpret. Then it's very hard to get the information we want. Okay? So the semantic layer, as we talked about, is a way to actually kind of embed the business meaning of all our tables, of all our data, right, in the columns and so forth. And there are two main components to this that I want to talk about. One is AI-enhanced semantics, and the idea here being that we've had semantic layers in the world for maybe decades, but it's been very hard for organizations, especially enterprises, to actually take advantage of them because there's so much manual work to create them and maintain them. And so for this to actually work, the semantic layers have to be auto-generated to a large extent. Yeah, there has to be a human in the loop, but we need to automate as much as possible in the creation and management of the semantic layers. And then the second thing is semantic search. Right? So it's one thing to create the semantic layer, but now when an agent wants to come and start looking at the data, they need to be able to, first of all, understand where that data lives, right? What tables are the right ones? And so semantic search is a key part of the semantic layer. And so you can think of a semantic layer basically as some kind of a graph with information in it, right? The relationships between all the different entities, the columns, the tables, and so forth, the lineage between them. It has to take into account, in order to return results, well, it has to take into account the popularity of different things, what's getting used, what's getting joined with other things. And then finally, it has to be exposed to all the different types of agents out there, whether it's a third-party agent, ChatGPT, Claude Code, right, using an MCP type interface, whether it's the Dremio agents that are kind of included in our user interface now. So all these have to be supported by the same semantic layer. And let's look at a simple example here, right? If, say, an analyst comes to one of these agents and says, what was the average agent performance, this is a support agent, right, for each team in Q2? So the first thing that's going to happen is the AI model is going to start doing its reasoning, right? It's going to break this question down into, OK, what do I need to figure out in order to actually answer this question? And that's kind of something that the models now are able to do. So what is it going to ask itself? It's going to ask, well, what is Q2? And as you probably know, Q2 could be defined differently in different organizations. It could be April to June. It could be May to July, right? So first thing is, okay, what is Q2? And it has to maybe use a tool called find metrics to find that information, right? Then it's going to ask itself, okay, I'm looking for a table that has customer sentiment information in it. So it has to find that table. And this is where that semantic search comes into play, right, as well. It has to find the table that has this kind of information. And then it has to understand the columns within that table, right? I'm sure you've seen tables that have a column called year. Well, is that the year I joined the company? Is that the year I joined the health plan? Is that the year I was born, right? Could mean lots of different things. And so it has to understand what does that actually mean. And so that's kind of the third thing it has to get. And this is a very, very trivial example, but you can imagine an organization doing 1 million queries a day, people asking all sorts of arbitrary things. When they ask questions in English, often they ask them very shortly. They don't provide all the information, what time frame they're talking about, what kind of revenue they want. They just, hey, give me the revenue, right? And we have to figure out what to do with that. So let me show you now, we talked about the AI enhanced semantics. Let me show you how easy we've made it to kind of start building those semantics into the semantic layer with the use of AI. So we're going to go back to that call logs table that we saw earlier, and we go to the details pane here, and we're going to click the generate wiki. So wiki is kind of the markdown, and you can see that the system uses AI to automatically come up with kind of a markdown description, which the user, the human in the loop, can just augment. It can add additional questions that might get asked. It can add definitions. Here's fiscal Q2 is April to June. So just various things, and over time, as you see how the system is behaving and performing, you can just add more things to your descriptions, your markdown, okay? We can go and create labels as well. So Dremio has labels on every table. You can go click the generate labels. That, again, uses AI to propose those. And we can go do this for these 2 other tables as well. It's as simple as clicking the generate wiki button. It goes in the generate labels button, and it will auto-generate those things. So much, much easier than creating these things by hand. You can also go and update it when you want to. But the goal is really to keep the human in the loop, but to reduce the amount of work that they have to do, to make the humans 10 times more productive, right? That's really the goal here. Okay, I want to focus now a little bit on the agents, right? We talked about, we're doing all of this in service of agents, right? And so I'd say at a high level, we look at kind of 2 different kinds of agents or classes of agents. We have the Dremio agent that is kind of built into the user interface. It is really designed for that analytics use case, both to make the business user more self-sufficient, to make them be their own analysts, if you will, and then also to make analysts 10 times more productive. And we're going to keep extending that. We're going to keep making it so that business users and analysts can do the work of data engineers to some extent. It won't be the whole thing because data engineering is a very complex role. It's like a superset of being an engineer, really. But we're going to keep pushing the boundaries on what's possible to do in a self-service manner. Okay? And so if you think about the roles in a company, really, when it comes to data, before all this AI stuff started happening, you had the data engineers. They were responsible for creating and managing data pipelines. You had the platform engineers that were responsible for keeping the system up and running and especially ensuring performance. And this often overlaps with data engineers. Data engineers also do kind of the performance and optimization of the tables. So it's not perfect separation here. You had analysts that are responsible for answering questions, building reports, building dashboards, things like that. And then finally, the business user, they have some question, they need an answer. Often they'll go to an analyst to get help with that kind of a thing. Okay, so these were kind of the by and large, the responsibilities. Now a lot of that is being either accelerated with agents, or in some cases, being made so you don't have to actually do all that work manually, right? And so if you think about what we're doing here, we have the data analyst agent, which I'll show you in a second, and you saw a glimpse of that earlier. That can take the form of the analyst agent inside of Dremio, or using something external like ChatGPT, right? That allows the business user to be their own analyst. It makes the analyst 10 times more productive. We've now built into Dremio what we call autonomous performance. Okay, the idea there being that we don't really want you to have to deal with the performance of tables, right? We have Iceberg clustering, autonomous reflections. We're automatically figuring out, based on the query workloads, what needs to be done to make things fast so that people don't have to go optimize performance manually. And then we have the data engineer. And our focus there really is to make the data engineer a lot more productive. right? To make it so that when they're using a tool like Cursor or Claude Code or something like that, they can work extremely efficiently, not just to write code, but to interact with the data, to see what impact their code changes are having on the data, for example, right? So we're doing a lot of work on that integration and making those tools, just like they've made engineers, software development a lot more productive, they're going to make data engineers a lot more productive. All of this under the hood really happens through a collection of various different tools, right? So in the case of the data analyst, and actually all of these agent experiences, you have tools for searching and understanding data, right? We talked about the semantic search. You have tools for interacting with the data itself through SQL. And of course, all of this sits on top of kind of that AI semantic layer in the intelligent query engine. So now I want to bring to the stage Andrew Balaban from PL Developments, and I'm excited to have him share with you what they're doing in the area of pharma. Thank you.
My name is Andrew Balaban. I work at PL Developments. I lead the Informational System Department. PL Developments is a pharmaceutical company. We produce about 5,000 items. Where is that? We produce about 5,000 items and supply them to major national retailers. If you buy an ibuprofen, for example, in a Walmart or CVS, probably it was produced by us. OK. When I started at PL Developments, our data landscape been familiar, like maybe too familiar. We had Oracle Stack, Oracle BI, Oracle Data Warehouse, Oracle Business Suite, everything together. And we've been running midnight ETL jobs that bring in data together, and people arriving at work, and they checking dashboards and seeing what happened yesterday, and asking questions about what's going on today. Did we ship this order? Do we have enough components to produce this job? And we kind of like, we'll do it. And we started to do a lot of mistakes. We created a lot of small PL SQL jobs. The job orchestrations was terrible. And then we created about 10 different layers of data. And we delivered something operational, but still we had a lot of problems. OK. One day we sit together and we decided, yeah, it's time to change something and bring something new. Our vision, our requirements to new system been more like what we want from the new system. First, we want NRT. Second, I didn't tell you, but this monster that we created with 10 layers, it started to consume about 30% of our ERP system resources, because we spin in 24/7 like a lot of jobs, and it's a real sequels, and it's kind of consuming a lot of resources. So we wanted to get rid of this. And also, it was time to reduce Oracle presence a little bit, because it was a little bit too much. OK, good. Long story short, we ended up with Postgres, Superset, and we found interest in product Aura CDC. It's Kafka-based streaming engine. It's parsing undo-redo logs, no SQLs, and delivering data to any source, like multiple destinations or whatever. OK, good. We delivered operational data. Users happy. Users predictable. They need now long-term analysis. And Postgres is not the best place for long-term analysis. You just run in, and it's kind of 10 seconds becomes minutes. Good. It's a new challenge. We started to look around, found Iceberg. We created a really ugly SQL, about 10 different joins, 12 different joins, or 5 unions, whatever. It was ugly. Oracle, 10 years analysis, 3 minutes. Postgres, 6 minutes. And we pushed everything into AWS and tried Athena, and the result was amazing, 6 seconds. Oh my God, this is what we need. So we don't need data warehouse. We need new Lakehouse, because our NRT data, like CDC, can stream everything to Lakehouse, and we will be happy. It's operational analysis and long-term analysis in one place. Everything fine, except we started to stream data. We brought Nessie, Trino, and started to stream. One day, performance was about 2 minutes, again, on a Lakehouse. What's going on? Metadata bloating. Because we continue streaming, Iceberg creates a lot of snapshots, and a couple tables ballooned. Oh my God, it's a new problem. Answer, more frequent compactions. Starting compactions, every, for example, hour, compaction cannot be completed. Why? Because you're still streaming data. So compaction started, you change the data, I cannot complete compaction. Okay. So that time, our company started to look at Alteryx. Alteryx, it's a self-service analytical tool. So we wanted our users to start looking at the data. But we needed security layer because Alteryx doesn't have it. Good. We looked around, like each of our houses, and this is how we first time met Dremio. What happened next? We actually put Dremio in the middle, created single point of access for all the users. We still have data warehouse, and we still have our dream about our lakehouse. So our semantic layer based on the views. And so when lakehouse will be fixed, we just swap them. Nothing worked. Actually, central point access of access and data warehouse still working fine, no problem. But we're still struggling with the lakehouse. One of our engineers, Alexei, he kind of like had another idea, like why you trying to put everything in one technology? If you imagine that small, very frequently changing table on the left side, for example, 100 tables and 1,000 updates, it doesn't belong to Lakehouse, but it's really good in a data warehouse. But here on the right side, you have huge table, huge data set, and probably it's immutable. Not probably, it's immutable. So in its spectrum. So you draw the line, respect the line. Those tables goes to data warehouse, those tables to Lakehouse. You have Dremio in the middle, federated SQL engine. You're doing this, your joins. You have NRT Lakehouse. It was a brilliant idea. So we put everything together, and finally it worked. It worked, and we've been ready for AI. We did a lot of experiments before. One example. You connect into Cloud Desktop, MCP, start a new chat. You just pull in resources, and like, yeah, this chat too long. Oh my God, good. So we tried many, many different things. Didn't work. They worked, they've been not impressive. Good, and then one of my friends also told me, like, try Cursor AI. We connected multiple MCPs to Cursor AI and started a simple conversation. And finally it worked. It was interesting, like simple question, APAR, and like more complicated. And we started to talk to our subject matter experts. They brought a lot of different cases. I will bring you a couple. One of them, please. So you connected everything to your Lakehouse, to Dremio, and you can ask question like, create email, send email to our customer name, and provide information about canceled orders, put in a table, customer, item number, our item number, description, quantity, cancellation reason. If you have open work order, put work order number and expected completion date. Okay? So it's literally less than a minute, and you have the full email ready to be sent, sorry. So a couple other examples. So quality example, it can go outside to FDA side, find the letter that belongs to customer, and suggest strategy. So for example, you have observation letter or for one of your vendor, and then put those items on hold temporarily unless everything will be completed, and can show you all the sales orders that you already shipped, and you can. It's interesting. It was a very good example. But one of our legals, they told us, guys, I want to have, we call it Beast. I want to have Beast on the next acquisition, because what you can do, you actually connect to company ERP system and start exploring the data. So, but in the same time, we started to understand we need much more guardrails. We are not ready to share it with people, because, you know, in a very short time, you can extract a lot of confidential information about company. We need to start working on security. We need to start working on a multiple guardrails. Okay. Sorry, I missed that. What we talked about? So we used Dremio, or the single point access for multiple users. And in the same time, we actually found a way how to limit other users on MCP layers. So for example, in an enterprise catalog, we can put this user has access to this to those tables, so this schema. And it's a customization of the MCP server, but it still works. Next, we actually need help with an RT, like Iceberg optimizations, because what we expect, Dremio has automatic compaction, automatic data maintenance, automatic Iceberg maintenance, but so we need to synchronize with our CDC tool, because so it can be time synchronization, of course. So we have some workarounds, but still, I mean, so if Dremio starts maintenance, we need maybe hook that, yeah, I'm starting, let's put our CDC solution on pause. Okay. And we just started this journey, and we need to understand better what we can do with the guardrails for the LLM systems. What I want to tell you at the end, so when we start in our conversation with subject matter experts, so it's predictable how it looks like. At the beginning, they tell us, oh my God, this is so amazing, this is magic. And then after 5 minutes, they kind of like, Balaban, thank you for making my job useless. People are afraid. They understand kind of like that it's something going to change. But we don't think it will be like that AI will replace people. What do we think? People who can use AI will replace people who doesn't. And I think like this is the future. So what I want to tell you, aim high, go home, break something, fix it better. Dremio is for us, and then probably will be for you, is a Swiss Army knife, because it can do a lot of different things. Thank you very much. Tomer, I want to bring you back on the scene.
All right, thank you, Andrew. That was super interesting, seeing how you're using Dremio's single pane of glass, single point of access, enabling you to use AI, integrate with Cursor. You know, it's been something I've observed internally as well. I see Sender using ChatGPT instead of Tableau, and our marketing team all using ChatGPT, now Claude Code a lot to do various things, all integrated with the Lakehouse, and kind of replacing that more static approach of like BI dashboards and reports. It's going to be a game changer for everybody here as well. Let me now show you what it looks like when you do analysis through the Dremio's internal agent, the integrated agent, and you'll see how easy it is to actually get started with that. All right, so I'm going to ask a question. And this first question is just kind of a metadata question. What data sets are available to analyze call logs, right? Just to show you kind of different kinds of questions you can ask here. So we try to show you as much as possible about how we're going about the process, right? You see different, what's called tool calls. So we're looking for different tables, and we show you that process. This is always improving. Like, we're always adding more and more capabilities here, but we strive to show you this because it kind of builds more trust. You see how things are actually happening. And so you get this result here. It's a description of, okay, these are the data sets that are relevant to call logs and customers and support engineers. It explains what these are, how you might want to join them. Now here's a more data question. What is the average customer support engineer performance for each team, right? And so again, we're going to go do some work here. We're creating SQL queries. We're validating those SQL queries. So this isn't just like, okay, take text, produce SQL, and go run the SQL, right? We create the SQL. We profile the values. We make sure that what we're doing is actually kind of seems correct, right? So we show you all those steps, and then we give you the answer, and escalation, support, triage. You can see the average number of tickets in each of these categories. So now for each customer industry, what % of calls were positive, the customer was happy, what % was negative, so we can see where we're doing well and where not so much, and you get charts. So that's another thing that you get here integrated into the agent experience. It's not just textual answers, but it's actually, you'll see visualizations, almost like you would in a BI tool, but ad hoc. You just ask a question. You can see, okay, transportation is the most happy customers. We do a good job there, with some analysis that that's the only 24 calls in the transportation category and way more in other categories, right? And so you can see all the kind of capabilities, everything from metadata type queries to data queries, and integrated visualizations. And there's a lot more coming in this area, being able to share these charts and share these scripts and export basically lots of interesting capabilities in this new integrated agent. Everything seemed pretty fast, right? When I was showing this, like you saw all these queries, they were running, things were coming back quickly. That's not something that can just happen, right? There's a lot that goes on behind the scenes that I want to give you a quick peek at how this actually happens. And if you've been following Dremio for a while, you'll recognize many of these kind of building blocks. But it's all about how do we provide a platform that makes your queries run really quickly behind the scenes so that when you're interacting with the agent, you're not waiting 10 minutes or an hour to get an answer, right? So one of the key capabilities in Dremio is something called reflections. Right? If you think about historically how data platforms worked, you had a bunch of data sitting around, whether tables or views or things like that. Somebody would try to use that, and things would be too slow. So you'd go to the data team, and the data team would start creating these derived tables. So various aggregate tables that are summarized, maybe pre-joined tables in the warehouse or the lakehouse. Sometimes that wasn't good enough, so they created cubes or created Tableau extracts or Power BI imports. So you had all these kind of copies of data sitting around, creating a lot of complexity in addition to the cost, right? All sorts of security problems because permissions don't travel with data. And then finally, some user at the top here would point to one of these like derived tables and get some quick answer, but through a very narrow lens. So what we did at Dremio is we created this thing called reflections, a little bit like indexes or materialized views, but very transparent to the end client, right? So the end client, the user is just interacting with tables and views, and behind the scenes, you have these various materializations. They could be aggregations or joins or things like that that are saved, by the way, as Iceberg tables in the object storage. And then when a new query comes in, the system automatically, and this is the key point, the system automatically rewrites those query plans internally to use the reflections. So a user is not even aware of these reflections, the client that's coming in. The reflections just kind of sit behind the scenes. The optimizer knows about them, ends up using them, and things are fast. But the challenge with reflections was always, well, how do I figure out the right ones to create, right? Like, should I create this aggregation or that join? And so we spent a number of years actually building this really interesting technology called autonomous reflections, where we study continuously the query patterns, we look at the query log, and we automatically figure out what reflections need to be created, also what reflections need to be dropped, right? So this kind of cycle of automation here, where based on the actual workloads that are happening, we determine and we figure out what are the right reflections to create. They get used. We're tracking the ROI on each of these reflections. And we're constantly doing this cost-benefit analysis and updating them. And by the way, they also get updated automatically, right? In fact, you have two choices. You can have it automatically updated every time there's an insert into, say, an Iceberg table, every time there's an update, or we can actually do it on a schedule if that, you prefer that kind of approach as well. So that's one thing, and that gives you, huge improvement in performance. And again, the key thing is you don't have to do anything. When we look at our, I'll show you in a second, the benchmark results, you'll see it's just much faster to use the platform without any effort. Another really important thing is something called clustering. And if you've used data lakes for a while, then you're probably familiar with this thing called partitioning. So if you don't do anything with a table, if you don't organize a table in any way, then the data is kind of just laid out kind of randomly. And yeah, it's easy to insert into a table like this. You just put stuff at the end when new data comes in, and you have this unpartitioned table. The problem is every query is going to be super expensive. You're going to have to scan the whole table to find any record or to do any kind of aggregation. It's going to be really, really slow. So then, we had in the world of data lakes this thing called partitioning for the last, decade, right? And partitioning was all about I separate physically different sets of files, all the records that have different values in that partition column or multiple columns, right? So, if it's partitioned by date, the data from each day is in a separate set of Parquet files. The problem with this is that the data could be skewed. It often is, right? You have a lot of shopping happens on the holiday season, and some days no shopping at all happens, right? If it's partitioned by customer ID, you have one customer has millions of records and one customer that has almost nothing, right? So you have this huge skew in these partitions. When, let's say, you get a new batch of records that has data from many different customers, let's say 10,000 new customers in that new batch of records that you're trying to ingest, well, you have to go insert data into 10,000 different partitions. And if there's one new record in each of those, for each of those customers, that means 10,000 new Parquet files, each one with one record. And you can see how this becomes, in order to just maintain performance of the system, you then have to compact those things, integrate them. So just one ingestion of 10,000 records, right? That's a small amount of data. Now you have 10,000 new files. You have to go compact 10,000 new partitions. It's just extremely slow and just not a great thing. And I'm sure many of you have had to like deal with these partitions and maintain them, and it's just it's a nightmare. So we created this new technology called clustering. Dremio is the only technology that does this on Iceberg. Okay? And what clustering does is it organizes the data, but it doesn't tie that to the physical layout, right? And so you can see in this example, we might have in one Parquet file records that have different values, but we try to keep together, close to each other, all the records that have the same value or nearby, close to each other values, right? And so at query time, you get the same kind of benefit in terms of performance as you get with partitioning, perhaps even better because the file sizes are now pretty much optimal, right? But you can still skip the areas of the data set that don't have the records because the min and max values, right, in each of these files are still pretty close to each other. So when you're trying to get a value that's outside of that min and max range, you can just skip that, right? So you don't have the skew problems. Ingestion, super easy. You got 10,000 new records, you put it at the end, and now you have a table that's 99% clustered and not 100% clustered. So you take a 1% performance hit, and the background will reorganize things and focus on the areas that are the least clustered, right? It doesn't have to be perfect. That's the beauty of this approach. It doesn't have to be fully, like if one of these green records is here, that's okay. It's going to have a very minor impact on performance, right? So clustering, huge benefit in terms of performance, huge benefit in terms of administration, kind of management of the system. You kind of can be hands-off. You don't have to constantly tune these tables. They just work. And then finally, this is kind of more, just keeping things healthy. There's too many small files. We, of course, bring them together. We clean up things that need to be cleaned up that aren't needed anymore. All this happens in the background. You don't have to deal with it. We just keep the system healthy. So that's what we mean when we say autonomous management. It's all about not needing to do things, right? And really important is the end result of all of this is that you don't have to do all these things that in the past you had to do, but also that you get a huge benefit in performance, right? This is like a TPCDS benchmark, terabyte of data, just as an example. And you can see how much faster Dremio is. It's like 20 times faster than the cloud data warehouse, right? And these are kind of the leading brands, leading vendors for cloud data warehouse. And if you compare it to like other like open source query engines, it's way more than 20x. But huge difference in performance. That also means a huge difference in cost, right? Because at the end of the day, like to get performance, the other way to do it is add a lot more hardware, a lot more nodes, and that of course costs a lot, right? So you don't want to do that. And so this is a big benefit, 20x performance and cost as well. And finally, I want to now show you what that actually looks like. And we're going to look at a simple demo here where we see the performance with and without autonomous reflections, okay? So we're going to go ask a question. And I think this is the same question we had earlier, right? And you can look at the speed here. So let's see, for each customer industry, what % of calls resulted in positive sentiment? So it's the same question we asked earlier. And let's see how long this takes, okay? And this is a super small data set, so it's not, I promise you, you're not going to have to wait hours. That's good. I didn't know they were going to do that. When's lunch? All right, so we got an answer. Let's see. It took 26 seconds. You can see that in the jobs tab within the product. And now we're going to turn on, you're not going to see it here, but we're going to turn on the autonomous reflections, right? So we're going to go to the reflections tab, and you're going to see this reflection here. This gets, again, these things get created automatically based on the workloads. And this is a simple cluster we're looking at right now, simple workload, but it's going to work on very, very complicated workloads. And now we're going to rerun that query. Okay, so we're going to retype this. And it doesn't have to be the exact same query, by the way. We kind of generalize these things. And you're going to see now that it comes back in something like 1 second, 2 seconds. If we go to the Jobs tab, see what it actually took. So yeah, about 1 second. And you can see that little lightning bolt. That means that this was accelerated because of a reflection. So you can see the difference here in terms of performance. And now just extrapolate that to like bigger data sets. We didn't want to do a demo here where it was like 1 hour versus like 20 seconds. But you can imagine if these things take a very long time, it just becomes frustrating to use the system. You become a lot less productive. And then, of course, we talked about the costs. So just to wrap things up, we started with this chart here. I've showed you a lot of different capabilities in the platform, all about powering agents on the data platform, whether it's Dremio's internal agent that's now available, or it's a variety of different external agents from kind of more consumer stuff like ChatGPT and Claude Web or desktop, Gemini, or it's more developer tools like Cursor, which we saw earlier, we heard about earlier, and Claude Code and things like that. So having all the data, having the context in a semantic layer, having all the data quality as part of that, and this automated performance. So with that, I want to thank you all for coming here.